Hi, my name is Rory McLaren. I'd like to show you why the Model MF102 training simulator is the most advanced in the world, and I get the idea that the term advanced is relative. And my point is that when it comes to teaching diagnostics, I don't believe this simulator has a match. So let me go ahead and just give you an idea using one example. Now, first and foremost, the Model MF102 comes with a complete curriculum for teaching both basics and troubleshooting hydraulic components, and also what I like to call performance testing the individual hydraulic components. Now, the troubleshooting course is designed to first and foremost teach the student how to test the individual components, meaning the pumps, the pressure control valves, the directional control valves, and after each one of those activities, or if you will, lessons, the student is given an assignment, and the student goes to the simulator with, of course, a workbook, and the student builds a system, and the system will have a fault in the component that the student is learning about. Once the student has learned how to test the individual components, then we have a little bit of fun, because now we're going to be looking at actual hydraulic systems. About 50% of the systems that are already uploaded into the computer on the Model MF102 are mobile, and the other 50% are industrial. As a matter of interest, if a company buys a 102 and wants to teach their own service technicians how to troubleshoot their own hydraulic systems, with a bit of help from us, we can upload your schematics into the computer so the students can learn how to troubleshoot your machines in the safety and comfort of a classroom rather than being in an active work area, which of course are going to have a lot of problems, especially related to noise. Now, also as a matter of interest, these are plug-and-play modules that attach to the Model MF102, and as you can see, I have two modules up. I have this valve here, which is a 3-section mobile valve, which is identical to any valve you would see on a front-end loader, a forklift, any type of mobile equipment like that. And that is a stacked valve module, which is classified more as an industrial valve, although it has found its way into many mobile applications. So what I'd like to show you right now is just one activity in the advanced troubleshooting level. And I've chosen a front-end loader. So in the student workbook, which comes with the course, the student workbook, and of course the full set of slides, as you can see an example of the slide here, this activity is in the book. So essentially what the student will do is go to the activity and then look at the problem. So in this particular case, this is a realistic operator complaint form, and we write it in the same language an operator would relay it to a technician, because an operator is not necessarily a technical guru, although some operators are mechanics that decided to become operators. However, in this particular instance, the type of machine is a front-end loader. The bucket raised lower cylinder is drifting down. So what we did here was we took all of the most common problems in a given piece of equipment. In this case, a vertical downdrift on a bucket is a fairly common problem. And then we also said that the operator told us that the problem doesn't seem to be as bad when the hydraulic oil is cold. Now, there are 3 classifications of problems in hydraulic systems. That is, we have problems that are related to wear. In this particular instance, if we have a wear-related problem, the symptom of that's going to be that as the oil heats up, the hydraulic system slows down, which, by the way, is the most common input in the industry. So that's the most common, let's call it, mechanism of failure. The other mechanisms of failure would be along the lines of, let's say, erratic operation, like a loose wire in a solenoid. That would be a symptom. The other one would be a catastrophic event where you've fragmented a hydraulic component. And the other one would be obstruction. Obstruction would be different to wear, in that if I get a piece of contamination that is obstructing, let's say, a check valve, the problem will occur suddenly. So the operator may say, well, it started this morning at 10 o'clock, whereby this particular type of problem would be getting progressively worse. And this should be able to be seen by the operator. If the operator has a temperature gauge in the cab, the operator can actually see this problem occurring, because as the components wear, the temperature will start to elevate. All right. Now, what the student will do is go to the simulator and build this replica system of the front-end loader. So as you can see, what I've done is I've connected up to this valve here for my demonstration, but I'm only going to use, in the interest of time, I'm just going to use 2 valves. So let's just say that I've got bucket raise and lower circuit, and I've got the rollback circuit, which is typically going to be on a front-end loader. I've added an electric motor here for fun, meaning that let's just say it's got a cooling fan, which is obviously not going to be operated with a directional control valve, but this just adds another dimension of diagnostics to this activity. So we're going to focus on bucket raise lower. Now, during the course of the fundamental hydraulics course, the student will have learned about mobile directional control valves. And in this particular instance, we've loaded this valve up with everything. It's got load check valves, it's got cylinder port relief valves, it's got anti-cavitation valves, and in this particular instance, the anti-cavitation cylinder port relief valve is a combination valve. In others, they are a single cylinder port relief and a single anti-cavitation. In the motor circuit, you've got dual anti-cavitation. All right. Now, this module is designed in fundamentals to teach a student how to set these valves. So that's the first step, is how do I set the main pressure relief valve and the cylinder port relief valve? Since they're in parallel, that's sometimes a challenge. But I'm not going to talk about that now. All I'm saying is that that's part of the fundamental training part of the curriculum that goes with the Model MF102. So the complaint we are dealing with right now is that the bucket raise lower cylinder is drifting down. Now, when I first started developing trainers 30 years ago, I sort of followed what everybody else was doing, and I would change out cartridges. I had 24 students in a class, and I was a very busy guy changing out cartridges to have problems in the circuit, and it didn't work. It was a complete disaster because, number one, I had to tell the student to look the other way, and then of course they start losing focus. Number two, I made a mess, and number three, it was awfully time consuming, and I had 6 or 8 simulators. I was running myself ragged, and I decided back then was, this has got to be, we got to do a better job than this. So what we see on competitive machines is we see just that, where the instructor's got to go behind the simulator to flip a switch, the instructor's got to open a valve, or like one particular, and I'm not saying this to berate other or put down our competitors by any means. All I'm saying is these are considerations in purchasing trainers to make the job of the instructor easy, and that is the instructor needs to be with the students, not running around like I used to, trying to figure out how to make these things fault. So we decided to build the fault in. In other words, every component on the simulator can morph instantaneously without me touching anything, literally, from a component that is in good working condition to a component that is worn out. So in other words, in this example, consider that if I've got a vertical downdrift on a front-end loader, it can only be 2 components. It can either be leaking in the cylinder or it can be leaking in the directional control valve. There aren't any other components that can cause this problem. Now let me talk a little bit about thermal imaging, because oftentimes students ask me why I don't depend more on thermal imaging, on heat sources to find problems. Well, let me give you a good example right now. First of all, if you're going to use a thermal image on a cylinder, where are you going to be when you're checking the temperature? Standing on a tire, on a step ladder? This thing's going to be active, and it's going to have to be loaded. So this to me would be a big problem if I couldn't distance myself from the machine. Number one. So it's a safety issue. Number two is look at how concentrated these valves are. In just a very, within inches of each other, I have 1, 2, 3 valves, all of which could be leaking. So if I have that as a heat source, how do I figure out which valve is leaking? Now, surely you're not going to do this. You're not going to say, well, I got a heat source there, the valve is leaking, so I'm going to pull it off. There are some machines out there, big mining loaders. The directional control valve, as I understand it from my clients in the mining industry, is $65,000. There's no way I'm taking that off until I find out where the leak is. And here's what's interesting, is most of the time it's in a cartridge. So think about that. You're going to replace a $65,000 valve or a $300 cartridge. That's the choice. The other thing is, what if this is a 10-bank valve on a mobile crane? You're going to take the whole thing off because one section or one port in one section is leaking? It's absurd. Nobody's got that kind of time and that kind of money. So what we want to do is we want to cut to the chase. We want to find out exactly where it's leaking. All right. So what I've done here is I've built this circuit on that simulator, the Model MF102, and let me talk a little bit about microleak testing. When I started out, after I learned about how to use a flow meter and I started going and doing testing in the field, it became evident to me immediately that I had some challenges. Number one, hydraulic systems, and I say this with all due respect to engineers, hydraulic systems are not designed to facilitate troubleshooting. I mean, many of them, you've got steel lines everywhere. How are you going to put a flow meter in a line when there's a steel line and you're out in the field? You can't run next door here and make a hydraulic hose. You're 150 miles away from a hose-making company. It's not going to happen. So what I decided was that flow meters have severe limitations. The only components you can satisfactorily and scientifically test with a flow meter are pumps and hydraulic motors. The rest is not going to happen. Now, you might say, well, I can test a cylinder or a direct control valve or a pressure relief valve with a flow meter, but the problem is, if you had 1 gallon a minute flowing through a directional control valve or a pressure relief valve, that's horrible amount of leakage. If you've got a 50-gallon a minute flow meter or a 30-gallon a minute flow meter, these flow meters, whether it's a turbine wheel flow meter or whether it's an analog flow meter, they only start reading flow at about 3 to 5 gallons a minute. So you're off the radar screen. It's not going to work. So really, when it comes to actually testing these kinds of valves, directional valves, pressure control valves, etc., there's only one way to do it. So I did a 10-year study of leakage rates in hydraulic components, and what I did during that 10 years is I developed standards for testing hydraulic components, and I wrote a book about that. So this book called Troubleshooting Hydraulic Components Using Leakage Path Analysis is, for all intents and purposes, a book of standards for testing hydraulic components. All right. Now, what I found as I started to look at leakage rates is the data in the industry has no data that tells me when a hydraulic component has reached its terminal leakage rate. In other words, what is the terminal leakage rate for a directional control valve or a pressure control valve? There is no such a thing. What I did when I started doing research some 20 years ago is I started looking at leakage rates in brand new components, and then components that were worn, I started looking at them and seeing, okay, when does a valve reach its terminal leakage rate? And I found that, let's say, sweet spot. All right. What I then did was I said, okay, let's find a way to test these components that's almost non-invasive. And so I started what I call, you can call it pressure decay, or what I call it microleak testing. I found that if I pushed manually, you can't power in, doesn't work. You can't have a power unit or some kind of portable power pump, doesn't work. If I could manually push oil with a hand pump into a hydraulic valve, I could feel, literally, it's a case of feeling the leakage. When I originally started this research, I had test tubes and I had steel lines coming off the valves, and I turned them around and brought them into a test tube so I could actually see the leakage rate on new valves and valves that were terminal. And I learned what that sweet spot is. I also learned that I had to have a pump that produced a certain amount of volume per stroke in order for it to work. In other words, this is a Microleak test pump on the simulator. Now, most people will look at that and say, well, no, that's a Porta-Power. Well, there's two reasons why you don't want to use a Porta-Power. Number one, it's a safety issue. The relief valve in the Microleak test pump is set at 3,000 psi, and the relief valve in a Porta-Power is set at 10,000 psi. So if you're testing a 1,500 psi check valve with a 10,000 psi valve, one stroke of the handle will put you at 10,000 psi. I think that's going to be highly dangerous. Number one. Number two, what is the volume of oil that this Porta-Power is producing? Could it give me a false positive or a false negative? Meaning this. Let's say I test a directional control valve, which is a leaker by design, and let's say it is brand new. And let's say the amount of oil coming out of the Porta-Power is so minute that it can't make up the leakage through a brand new valve. That'll tell me the valve is bad when the valve is actually good. Now let's go the other way. Let's say it's a two-stage Porta-Power that just produces a huge amount of flow, and let's say the valve is leaking. But I put enough volume into it where I can bring the pressure up. That's going to tell me a valve is good when it's actually bad. So anything to do with a Porta-Power is off the table as far as I'm concerned. And that's why I developed a pump that was unique to Microleak testing. So what I'm going to demonstrate is how to find this problem using the Microleak test. And, you know, let's face it. The error rate in our country is 85%. And there are some people who actually challenge me on my numbers. They say, where did you get these numbers from? Well, I get them from the horse's mouth. In other words, let me give you an example. Using this valve. Before I show my students how to test a valve, a mobile valve, I ask them this question. Have you ever had any reason to believe that you had a vertical downdrift on a cylinder and the oil was leaking into the directional control valve? And when they say yes, I ask them what they did. They said they replaced the valve. So without exception, in 20 years, I have never had anybody tell me that they were able to go and find the leak in that valve. They found the valve was leaking, but they never pinpointed the leakage. That's the problem. So this is now 100% of students that answered, and since some students don't like to talk, I gave that a margin of error of 20%. So here's the bottom line. In my research, through the years, I have learned that the troubleshooting error rate in hydraulics is about 80%. That means 80% of the components removed from service have nothing wrong with them. There is a critical shortage of hydraulic diagnostic technicians, not only in our country, but in the world. If a student learns Microleak testing or a technician, the error rate is guaranteed to drop to less than 1%. So in other words, what I'm saying is, even if a school, a training organization doesn't have a Model MF102, it would be prudent to teach students Microleak testing, if for no other reason than safety. And the reason why is because when we do Microleak testing, the machine is shut off. There's nothing running. That's an element of safety already. And another distinct advantage of Microleak testing is it's almost non-invasive, as you will see, and of course, it's 100% accurate. There's no error. There's no, I need to get a second opinion. it's 100% accurate. So microleak testing is the only way to fly. All right, let me show you. So the Model MF102 is the most advanced hydraulic training simulator in the world from this point of view. When I go into the screen, I have, and I'm now talking about the advanced troubleshooting, not the baby steps into the individual components, but advanced. What we have here is we have a number of machines, and we've used a couple of common machines that most people can understand. In other words, forklifts. We've got a forklift, we've got an asphalt paver, a dump truck, and so on. So what I'm going to select is I'm going to select the front end loader, and of course I've got all these different machines. Like I said, there's even a drill in here, and I've got a number of activities. So as we can see, I've got the front end loader here, and I have the problem, which is problem number 7, which says the raised lower cylinder is drifting down. All right, let's select that. Now, once again, what is happening on the screen is mirroring what the student is doing in the activity in the book. That goes with the activity. And then what the student is going to do is build the circuit, as I explained, and that's what I've done here. The circuit is built, albeit a portion of the circuit in the interest of time. Now, here's what's interesting. I'm going to start this up, and I'm going to run it. So what is going to happen now is this is the raised lower cylinder here, and that, let's say, is the rollback cylinder. So the vertical cylinder is the raised lower for the bucket. All right, now, the Model MF102 conveniently has a load capability, because without load you can't learn how to troubleshoot. You've got to have load so you can drift, so things can happen. I've got a 100-pound weight down below, and I can start this up, and I can run it with or without load. So let's begin by running it without load. So you can see the cylinder rod going up, going down. Pressure relatively low. Now I'm going to move the latch, because that's all it takes. I'm going to move the latch, and I'm going to raise the load. So I'm now onto the load, and I'm going to hold. So as you can see, it's in perfect working condition. So now the student has built the circuit, set the valves, and is now ready to go and learn how to troubleshoot the system. Just a little bit more about the screen here. When I go to the next screen, two things will happen. So first and foremost, the build screen, in other words, I guess you might be asking yourself, well, how does this thing know when to make the fault? In other words, I want the seal in that cylinder to be leaking, I want the directional control valve to be leaking, a cartridge valve to be leaking. How does that happen? Well, that actually happens, like I said earlier, automatically. Here's how it works. What happens when you select the next screen is the computer enables the fault. So that means that either the cylinder seal is leaking, the directional control valve is leaking, or both. Now, if you look at the screen, you'll see we have an inventory shelf here that has in inventory all the components that are in the circuit. When I find a problem, let's say I test the cylinder is leaking. If I touch the symbol for the cylinder on the screen, it'll ask me what kind of test do you want to do. It'll ask me, do I want to replace the cylinder? It'll ask me if the test was successful. In other words, did the cylinder work or did it leak? And then it'll ask me, do you want to replace the cylinder? And I'm either going to say yes or no. If I say yes, it'll remove the cylinder from inventory and put it on the machine, as if you went to the warehouse, got yourself a new cylinder, and stuck it on the machine. Let's look at that. So I'm going to go back, and I'm going to finish this activity. I'm going to go back to raise lower, and I'm going to now just go through this activity. As we said, so let's restart, and let's revisit with this again. I'm going to raise the load, and as you can see, the load is holding. That's where you want to start. All right, now, as we said, when I go to the next screen, it will enable the fault, which means now this time, the cylinder is going to be drifting. Observe. So I'm going to raise, and the cylinder's drifting. Now notice I never went anywhere. I didn't go behind the simulator and move a switch. I didn't open a valve. This just happened automatically. So the instructor's job is to be with the student, not running around trying to figure out what fault to put in a simulator. All right, now, here's what's really cool. The computer is programmed so that you can actually do competency testing. So not only can you use this to teach the students how to troubleshoot machines, but it will also help them to have a thought process. In other words, one of the things that's missing in troubleshooting is the thinking side of troubleshooting. One of the things we didn't figure when we designed this training system was what it would do, the powerful impact it would have on getting students to think things through. Now, one of the things that I say to my students when I'm teaching using this machine is when I give you these kinds of assignments, watch the students that when I give them the assignment, because students are adventurous, they're energetic, they want to get into it because it's really exciting, so they want to go and solve a problem. Watch the difference between the student that sits down and the students that sit down, because it's team-based training, that sit down together and plan a troubleshooting strategy versus the ones who jump right out of their seats and go straight to the simulators. You'll see a vast difference here. The ones that sit down and plan the strategy, because remember, you're launching off what we've taught in fundamental troubleshooting. This is advanced. So you're obviously being trained to think the thought process. What are the symptoms? What components cannot cause this problem? In other words, you've got to look at it, the schematic, and I call it, in the activity, you'll see I draw a line. Troubleshooting is a journey. There's a beginning point and an ending point, and we plotted on that journey. So it's as if I was going to, let's say, visit Chicago, and I was getting in my car, or at least I was planning the trip with my family, and I said, okay, tomorrow we'll stop here, the next day we'll stop there, the next day there's a museum here, we'll stop there. That's troubleshooting for you. You start here, this could be a suspect component, I'm then going to go to stop and look at this component, and it'll end. So in other words, there's a beginning point and an ending point. That's a very critical component of understanding how to troubleshoot, at least disciplining yourself how to troubleshoot hydraulic systems. All right, so let's move forward here. So, competency testing. What this computer is doing is it's got a timer on it. So let's say the instructor gives a student 45 minutes for this activity. Then what will happen is if you go over 45 minutes, it'll start penalizing the student. So you've got a time frame to work within, which is going to happen at work anyway. You're going to have to fix this machine as quickly as possible because the production people are waiting for the machine, number one. Number two, it's also going to count the number of attempts you make to find the problem. In other words, think about it like this. I have only 2 attempts on this activity because there's only 2 things that can be wrong with this machine. The cylinder could be leaking or the directional control valve could be leaking. Can't be anything else. So I've got 2 attempts. However, I could have 2 attempts and I could say, well, it could be the pump. And if I touch the pump, it'll ask me, do you want to replace the pump? And if I say yes, it's going to replace the pump. But you're going to get penalized because the pump could not possibly cause this problem. So, number one, you've got a time penalty. Number 2, you've got 2 attempts. Now, you can solve the problem in 1 attempt. In other words, let's say I test the directional control valve and it passes the test. Well, then isn't it over? Isn't that the beauty of it? If I test the directional control valve and it passes the test, then I'm going to replace the cylinder. I'm not even going to test it. Why would you test it? There isn't anything else that could be causing the problem. So you can see, that's 15 minutes and the job's over. I'll show you. So it's looking at the number of attempts you make, and then, of course, it's going to beat you up if you replace components that cannot possibly be the problem. So it's really, really cool when it comes to, let's say, end of quarter competency testing. One other idea, if anybody's hiring technicians and you want to know what the technician's skill sets are with respect to troubleshooting, no problem. Give them a forklift with a vertical downdrift. It's about as simple as it's going to get, and then go away. You don't have to be there, just go away. Come back later, and then you can go back in. It's password protected. The instructor can go back in, and the instructor can see the entire thought process on that whole troubleshooting that forklift. So you can either see if this person is competent or incompetent to troubleshoot something as simple as a forklift. All right, so we know that the cylinder is leaking. So now what we want to do is you want to test it. So let's do that. I'm going to do a microleak test on the cylinder. So when we're testing cylinders, always test a cylinder in the opposite direction to which you're drifting. In other words, let's assume, since I don't know the cylinder necessarily, it's got two seals, one for up and one for down. That's why you test in the opposite direction to which you're drifting. If you've got two seals and you're drifting down and you test in the top port, you're going to go to the seal that might not have anything wrong with it, and it's going to tell you everything's fine. It's a false positive. So you always test in the opposite direction to which you're drifting. You'll also notice when you're doing microleak testing is that all the loads are down. This is a safety. The microleak testing is the safest way to test any hydraulic component. So everything's down on the ground. So there's no gravity loads to worry about, nothing to worry about. All right, so the machine is shut down, we've locked it out, and now what I'm going to do is I'm going to pull the lines. Now, we must be able to de-energize the hydraulic system, so make sure before you pull a line that you follow the manufacturer's recommendations for getting the stored energy out of the hydraulic system. Follow the manufacturer's recommendations. You have to verify that the hydraulic cylinder, or at least the oil, is at a zero energy state. All right, now, I'm going to get a T, and I'm going to put a T on my microleak tester so I can put a pressure gauge on it. So let's do that. And then what I'm going to do as a matter of course is I'm just going to do a quick microleak test on my tester to make sure it's in good working condition, because you don't want to get a false negative whereby you test, the test fails and the problem is not the valve, it's the microleak tester. So let's pump in. So I'm already doing what is called a microleak test. So I'm now going to pump up to any value, because you don't care about pressure here. Pressure is not an issue, it's about leakage. And you can see it's holding. So now what I'm going to do is I'm going to connect a line, a transmission line, from the microleak tester. I'm going to take a transmission line here from the microleak tester, and I'm going to go to the bottom port of the cylinder. Okay, so let's go to the bottom port of the cylinder. Now, in the field, I would take the line off the top. Just take it off. Now, remember, it's safe because nothing's running. This machine is shut down. And the reason why you want to take the line off the other side of the cylinder is because if you're going from the top of the cylinder to a closed valve, it's going to give you a false positive. So what you want to be able to do is see if it's leaking. Now, some people say, well, how much oil does that thing hold? Because you're going to have to fill the cylinder. Well, it's not going to take much oil because the cylinder's already all the way down, so it's not going to have much volume. And if you need to fill it once or twice, then of course you can do that, no problem. All right, so that's certainly feasible in that particular instance. So what I'm going to do now, because I'm running quick disconnect, is I'm going to run a line from the top port of the cylinder back to the hydraulic reservoir. Now, I'm ready to do a microleak test, which is the safest test you can possibly do on a hydraulic cylinder. So here we go. Close the valve and then start to pump. As we can see, there's absolutely no movement of the cylinder whatsoever. So it's clearly leaking. So what do? I go to the schematic and I touch the symbol. It says double rod cylinder, test, replace, do nothing. We tested it. What test did I use? It says microleak flow test or pressure test. I used a microleak test, and the microleak test is done. I'm done with the test. It says the test passed, the test failed, it failed. Do you want to keep the cylinder, replace it? And then I'm asked again, because you don't want to make a mistake, I'm asked again, do you want to replace it? Yes, I do. And so there you go. the cylinder's been replaced. Now, obviously, you can test it. Let's do that. Remember, I didn't go out of sight, but I did replace the cylinder, meaning that now it doesn't leak anymore. So let's do this. I'm going to test it. There it goes. It's raising the load. So you see, it now passes the test. That's really cool. Now, we had two suspects, right? We also had a suspect in the directional control valve. So what I'm going to do is I'm going to do a microleak test on the directional control valve. When testing a directional control valve with a microleak test pump, always go to the suspect port. You don't have to take any lines off, only the one that you're leaking into. So for example, the line at the bottom of the cylinder, so this line was going to the top of the cylinder. So let's just put it back so we can see clearly what I'm doing. This line went to the top of the cylinder, and this line went to the bottom of the cylinder, so let's put it back where it belongs. And then the line on the bottom of the cylinder is going into the B port of my directional control valve, so that's all I want to remove. So that comes off, and I take the line from my microleak tester into the B port of my directional control valve. Now, interestingly, in a directional control valve, when you are microleak testing it, you're testing everything in that port. So right now, looking at the schematic, I'm testing to see if it's leaking in the cartridge, the cylinder port, relief valve, anti-cavitation valve. I'm looking at the seals, and I'm looking at it to see if it's leaking across the spool bore wear. I'm looking at all of that. Let's see if it passes the test. So I'm going to run the test now on a microleak into that B port. And as you can see, it's defective. It's defective. Now, I'm not going to go into right now how to actually go in and pinpoint the leakage path. In the interest of time, I'm not going to do that. But at least I know right now that it is leaking. So let's replace it. So I'm going to go and replace the directional control valve. So the directional control valve, I test it. I'm doing a microleak test. I'm done with the test. Test failed. Replace it, and I'm asked again, do you want to replace it? I'm going to say, yes, I do. And it's replaced the valve. Let's see if that has fixed the valve. So now I'm going to run a microleak test on my directional control valve that I just removed out of inventory and put on the machine. And as you can see, it's fixed. So that solved the problem. Now, when the student is done with the activity, the student is going to hit finish, and it's going to give the student a report. So let's see what my report looks like here. It says, you practiced excellent diagnostic skills, you completed the task satisfactorily, enter the amount of time it took to complete the activity on the maintenance action form, and it's got a summary. The summary says the double rod cylinder tested using microleak test failed. It says the cylinder was replaced. It also said that the directional control valve failed, and it says it too was replaced. Now, where are you going to find a hydraulic training system anywhere that's going to help a student learn how to do diagnostics like this? So for some manufacturers that have asked us, that have these in their training centers, they've actually asked us to put their own valve. So they've sent us their own valve, and because we are very good at creating leakage paths inside the valves. We're very good at doing that. So we create all the problems that they typically have in the field. We tie it into the computer, and their own technicians are learning how to test their own machines in the comfort of their classrooms. So, as I said, I think you will agree with me now when I say that the Model MF102 is the most advanced hydraulic training system in the world. So once again, it's designed to teach basic through advanced hydraulics, 40 hours plus. It comes with a complete curriculum and all the textbooks. And it's designed to teach a 40-hour plus course in basic through advanced diagnostics. It has no equal. So visit www.fpti.org if you want to learn more about this phenomenal trainer. And we will be doing additional videos about other features of this trainer. This is a feature-loaded piece of training equipment. It was designed in my classroom, and it's state-of-the-art. So thanks for watching, and let us know if we can help you with any of your troubleshooting issues. And for schools that don't have these trainers that want to learn hydraulics, remember, all of our My Train the Trainer courses for taxpayer-funded schools are complimentary. If you're a taxpayer-funded school, you can come to our courses, complimentary courses, and you don't have to have our equipment to do that. So, thanks very much for watching. Be safe, and tune in again. We'll have some more videos later on.